Hello all and welcome back. Today we're going to be looking at another paper. We're going to be looking at the Edexcel 2024 Foundation Paper 2. This is a calculator paper, so feel free to get your calculators at the ready. But yeah, I'll link all of the questions below so you can click to particular ones and get there nice and quickly. But otherwise, if you want to sit through the whole thing and go along with me, we'll dive into it now and see how we get on. So yeah, without further ado, let's dive in. So let's have a look at what we've got here. We've got question 1 right at the start here. Let's see what's going on here. So we want to order the numbers from smallest to largest. So that's going to be starting with our negative numbers. -3, -1, 2, 4, 7. There we go. So remember, as negative numbers get more negative, they kind of get bigger. So yeah, we're starting with the biggest negative number, right? And then switching as they become positive. Cool, next one. 5,000 milliliters to liters. Okay, a little bit of a hint here in the start here. The mil, a bit of a giveaway, meaning 1,000 milliliters to 1 liter. So 5,000 milliliters is going to be 5 liters. Question 3, 31 over 100 is a decimal. Okay, you might be able to do it as a percentage. Would quickly go to 31%. But of course we want it as a decimal. It's going to be 0.31. Nice. Write down the multiple of 7 that is between 30 and 40. Okay, maybe you know this off the top of your head, but if you didn't, all you're doing is going through your 7 times table. 7, 14, 21, 28, 35. Look at that, there it is. Boom, 35. Cool. Right, off to a good start here. Complete this statement below to make it correct. Something times m is 2 times m. All right, that kind of gives that one away. Nice, and we're doing very well. All right. Ben sells houses. The pictogram shows information about the number of houses Ben sold in each of the first 3 months of last year. Okay, and a big square represents 4. Therefore, this small square, that's going to represent 1. This half a square rectangle thing is going to be 2. Write down the number of houses sold in January. All right, so we're going to get 4, 4 again, and that's going to be a 2. So that's going to be 10 in total. In April, Ben sold 11 houses. Okay, represent this. Okay, so a big square is going to be 4 at a time. 4 plus 4 is going to be 8, and then we're going to need a 3 to represent the 11. Cool, okay, there we go. Ben in total sold 60 houses in the first 5 months of last year, so work out the number of houses he sold in May. Okay, we're going to have to run through all of this now and figure out how many each of these are. So that was a 10. 4 plus 4 plus 1, it's going to be 9. 4 plus 4 plus 4 is 12. 4 plus 4 plus the 3, as we found out down here, was 11. Cool, so we're going to have to work out the total of these. And then from there, we can work out the difference between that total and our target of 60. So what's the nicest way to do this? I'd say the 9 and 11 is going to be 20, and then you're adding 22 to 20. So we're at 42 in total here. And we wanted to get to 60. 60 take away 42 gives 18. So there's going to be 18 in May. Work out the number. Yeah, so it just asked for the number sold in May. So that's going to be 18. Right, we looked at all of these. They came to 42, took that away from 60. Do have a calculator. I kind of blitzed through that in my head, but yeah, there you go. Nice. Cool. Okay, we've got some measuring ones. If you had this in front of you, get a ruler out, and you'll find that it's actually 8.7 centimeters. Be careful, you want it to start at the end, go all the way to the end. I'm sure you can do that. Next, same again. You're measuring an angle, this time protractor. Line up your 0 degrees with one of these and then use the protractor to figure out how much this is going to be. And this comes to 67 degrees. Okay, nice. In the space below, draw a hexagon. Okay, hexagons have 6 sides. It doesn't necessarily say it needs to be regular, so I'd get your ruler out and draw something with 6 sides. Typically something like this. You want that sort of honeycomb design that you'd see. There you go, something like this. Okay. The points A and B are shown on a grid. Write down the coordinates of point A. Right? Coordinates, you describe your x coordinate first and then your y coordinate second. So this is 2 across and 1 up. So that's going to be 2, 1. Find the coordinates of the midpoint of AB. That's an interesting one. So there's a few different ways of doing this. I think for the case of hours, how would you go about doing this? I would use a ruler and I would go... There's a few different ways. You could use a ruler, measure the distance and find the midpoint in the distance. That would, and then see what coordinate is there. That would work. For me, I think the way that I would do it is go, well, we want to find the midpoint of AB, right? And we know that to get from A to B, we're going to the left 4 times, and then we're going down 1, 2, 3, 4, 5, 6. So we've gone left 4, right? And we've gone down 6. If we want the midpoint, well, we want half of these, right? So actually, to get our midpoint, we're going to go left. I'll change color here. We're going to go to the left 2, and we're going to go down 3. All right, so from A, across 2, down 3, and we end up here. I think my black line was slightly off there. And what are the coordinates at this point? Well, it hasn't moved left or right at all, but it is down 2, so 0, -2. And last but not least, on the grid, mark with a cross X, the point with the coordinates -4, 2. All right, -4, up 2. There it is. That's point C. Nice. Okay. So Anil has a job as a driver. He is paid for each mile he drives. He's also paid expenses. One week, Anil writes down the distance readings from his car. Okay, he starts with that many miles and then finishes with that many miles. For this week, Anil is paid 47p for each mile he drives. He's also paid £80. Okay, so we need to work out how far he's gone here and then multiply it by the 47p and then add the £80, okay? So let's have a look at this. So the distance he's travelled is going to be the end of the week minus the start of the week. Okay, I can't do that in my head. So that's going to be a 47879 minus 47241, 638 miles. Now, he gets paid 47p for each mile. So we're going to do 638 times by, well, we could do 47p, but I'd suggest that actually, given that the rest of the question is in pounds, and it wants the answer in pounds, let's do this as 0.47 pounds. Okay, so we're going to do that times by 0.47, and that leaves us with £299.86. Okay, actually, strictly speaking, don't need the pence there. Excellent. He was also paid the expenses of £80. So there you go. We want this 299.86, and we're going to add the 80 to it. Bosh. And we're left with £379.86. Give your answer in pounds. Yeah, there we go. That is it. Boom. Happy days. Let's move on. Anita throws a coin 3 times. Each time the coin lands on heads or tails. List all possible outcomes. All right, you're flipping a coin. What's it going to land on if you flipped it 3 times? We've got to just run through everything here. So let's start with heads, heads, heads. Next one could be heads, heads, tails. The next one could be heads, tails, heads. The next could be tails, heads, heads. All right, we've run through all 3 of heads. We've run through everything where there's 2 heads. Now we want where there's only 1 head. So heads, tails, tails. We could then have tails, head, tails. We could also have tails, tails, heads. And last but not least, we can get tails, tails, tails. 1, 2, 3, 4, 5, 6, 7, 8. Cool. All right, question 11. We've got a spinner, and the arrow can land on a 1, 2, or a 3. The probability that the arrow will land on a 2 is 1/3 because the spinner has 3 sections. Why is this incorrect? Okay, she is not correct, but why is she incorrect? Well, each area is not the same. 1, 2, 3 is not equal. right? So actually the probability of it landing on a 2 is going to be less because it's a smaller area. And there's, with these sorts of questions, you can never, add too much information. Will be less. Area is smaller. Nice. And by area, I mean, think about the area where the tip of that arrow can actually land, okay? Cool, on to question 12. Sarah buys 24 bars of chocolates. 2/3 of the 24 bars of white chocolate. All right, let's do this as though it's a diagram. So we've got 24 in total. 2/3 of the 24 bars are white, okay? Let's figure out how many are white. So 2/3 of 24, divide by 3 times by 2. 24 divided 3 is 8. 8 times 2 is 16, so 16 are white chocolate. The rest of the 24 bars are milk chocolate. Okay, so the remainder are milk. So we've got 8 milk. Each milk chocolate bar has a weight of 35 grams. Work out the total weight of the milk chocolate bars she buys. So we're looking at these specific 8 down here, and we're going, all right, each of these is 35 grams. So we're going to just, 35 grams times by 8. Let's see what the calculator says. 8 times 35, 280. There you are. There it is, 280 grams. Boom. Next up, question 13, our first little bit of algebra coming into play here. Simplify 2c times by 3d's. Now, multiplication has this property where actually the order doesn't matter. 2 times by c times by 3 times by d is exactly the same as saying 2 times by 3 times by c times by d, right? Looking at this, 2 times 3, 6, cd, can you simplify that? So 6 cd, that's as good as you're going to get. Next up, we've got some substitution, or we've got values for x and y, and we're just going to plug them into our equation. So t is equal to x, which is 3. And then over here, we've got add 2 times by, I'm going to put this in brackets, minus 4. I'm putting it in brackets just to make sure that we know that that negative is there. You've got a calculator. Don't risk it. Plug it in. I'm sure a lot of you, though, would be absolutely capable of doing that. So, yeah, minus 5. Okay, question 14. On Monday, Lizzie cycled 36 kilometers in 3 hours. Work out her average speed. Okay, and this is in kilometers per hour, so we're not dealing with any conversions here yet. So speed is equal to distance divided by time. Okay, we have a distance and we have a time. So our speed would just be 36 divided by 3. We've got a calculator, use it. 36 divided by 3 is 12. On Tuesday, Lizzie cycled 36 kilometers, an average speed of 16 kilometers per hour. Okay. Yep, okay. So she does another 36 kilometers but goes slightly faster. Lizzie says that the total time she cycled on Monday and Tuesday was less than 5 hours and 20 minutes. Oh, okay. So let's see what we can do here. So on Monday, we know that she rode for 3 hours. But on Tuesday, we don't currently know how long she's ridden for, right? We know the distance and we know the speed. So we're actually going to have to take our equation and figure out what's going on. Now, I know a lot of you like this triangle way of looking at these equations. So absolutely, let's do this. We want to find the time. That means we're going to cover up the t. There it is, it's gone. And we're left with d over s. We want distance over speed. In this case, that means we've got 36 divided by 16. Now let's throw that into our calculator and see what it gives us. And we get 2.25. Or, I think a slightly nicer way of doing this is 2 1/4. Mixed fractions, right? Going to be very nice. Mixed numbers, right? Now, why is this particularly nice? Well, look, we're dealing with hours, but our answer up here, this 5 hours and 20 minutes, is hours and minutes. So, what is our total time? Well, it's the 3 hours plus the 2 1/4 here. which is going to be a total of 5 hours and a quarter. But what's a quarter of an hour? Well, actually, to convert it normally is quite difficult, but we know the saying a quarter of an hour. A quarter of an hour is 15 minutes. And if you did want to do this properly, what you need to do is get it something over 60. There's 60 minutes in an hour. What do you multiply 4 by to get to 60? 15. So there it is. That's how you do it, I suppose, the more lengthy way. And look at this. She's absolutely right. 5 hours and 15 minutes is definitely less than 5 hours and 20 minutes. Nice. On to question 15 now. £3,500 is invested in a bank for 6 years. The bank pays a simple interest at a rate of 2.5% per year. Work out the total amount of simple interest. So, simple interest, right? We look at the first year and we work out how much 2.5% was. We're just going to add that each year for 6 years. Okay, and we want to work out the amount of interest we got, not the new amount, like the new total value, if that makes sense. So, we have 3,500 and we want to find 2.5%. So we're going to multiply it by 0.025. In other words, this is the decimalized version of 2.5%. Let's see what this gives us. So 3,500 times by 0.025. Bang, £87.50. Great. So, given that this is happening for 6 years, we've got to multiply it by 6. 87.50 times by 6. So this is in 1 year, but over the span of 6 years, she's going to get 6 times as much, giving us £525. Nice. Question 16. Use the graph to change between ounces and grams. Okay, so first of all, we're asked to convert 6 ounces into grams. Okay, so what we're going to do, we're looking for the ounces and the 6, and we're going to go follow that line up. Use a ruler. I'm not doing it particularly neatly here, and that comes to about this point here. I would say that that's coming at 170 grams. Okay, this line is indicating the point where you are converting, right? So that line is what that's telling us. So for our part 1 here, we've got 170 grams. Then we've got change 1 kilogram into ounces. Now that's interesting because we don't actually have a kilogram on our y-axis, but we do have 100 and we do have 200. So maybe we should take one of these. I'm going to take 100. We take 100, we end up at this point here, which is roughly here, which I'm going to say is about 3.5. So that means that if 100 grams is equal to 3.5 ounces, what do you get if you've got 1 kilogram? Well, how do we get from 100 grams to 1 kilogram? We times by 10. So we're going to do exactly the same thing over here, and you're left with 35 ounces. Nice. OZ, by the way, is I think the short form of ounces, but you don't really need to worry about that. Here it has the word ounces. Same way grams up here. They haven't used G, they've said grams. Okay, question 17. Here is a triangle. Oh, we're not told very much about that, are we? But we're given a fair amount of space. The region R consists of all the points inside the triangle that are less than 4 centimeters from A and closer to C than to B. Right, okay, a loci question. On the diagram by shading the region, show on the diagram the region R. Okay, so for this, you basically just need to measure out the two facts. So less than 4 centimeters than A. So for this, you're going to get your compass, and you'll want to measure out 4 centimeters here. And draw your arc, defining what is true for this fact. And then we want to consider what points are closer to C than to B. Now to do this, we actually just want to find the midpoint between them. Probably somewhere like here-ish, right? That's about the midpoint. And actually just drawing a vertical line here ensures that everything to the left of it is closer to C and everything to the right of it is closer to B. Lo and behold, we're left with our little bit of a region up here that is true for both. It's closer to B, so it's to the right of this line, but it's also within 4 centimeters of A. And this is our region. Nice. Question 18. Miss Simpson organised a school trip for 66 children. The total cost of the trip was £1,800. The school paid 56% of the total cost. The rest was divided equally between the 66 children. Okay, so we want to find how much of this £1,800 was paid by the students. Now that's going to be not the 56% because that was paid by the school, but the remainder, the 44%. So we want 44% of this, which is the same as saying 1,800 times by 0.44. So let's see what that gives us. 800 times by 0.44, £792. Okay. This cost was then equally divided between the 66 children. So to get our final answer, we're going to take this value, that's the total amount that the students were paying, and then divide it by the 66, which gives us £12. Nice. Okay, question 19. This is just a calculator question that's a bit scary, so just take your time putting in the values here. Maybe work through this one with me. 1.7 cubed over 4.6 squared. That's square root, right? You want it to be going all the way to the end there, all the way. It can sometimes on your calculator only go part of the way and then stop. Just double check looking at it. Does that seem reasonable? Yeah, I think it is. I got 0.5170189,759. And then we want this correct to two significant figures. Significant figures, we look at the first digits. We ignore the zeros. We look at the digits. So here's our first one. Here's my second one. Do we round it up? Absolutely we do. The 7 is going to force it to go up. So we've got 0.52 as our answer here. Fantastic. Cool. Here we have question 20, a right angle triangle. Okay, immediately when you see a right angle triangle, you want to be thinking, well, there's only two things. There's only two things I can do with them. Trig, Pythag. Now, in the case of this question, we want to find another length. We want to find CB. All right, we've got two lengths and we want to find a third one, Pythag. If we had anything to do with finding the angles, we'd be going down the trig route. But here it's Pythag. Now, the Pythagorean formula is a squared plus b squared equals c squared, where c squared is our hypotenuse. Our hypotenuse is the longest side. So actually, in this case, I'd start by just filling in your values. A and B are interchangeable, by the way. You're more than welcome to interchange them. They're just the two shorter sides. So let's say A is our 10. B is our mystery side. So let's make it x squared because we've labelled it x. And then C is going to be our 19 squared. Let's fill this all in. Why not? Let's do it now. So we get 100 plus x squared is equal to 19 squared, surprisingly large, 361. Now to solve for x, we're going to take away the 100. X squared is equal to 261. And x is therefore equal to the square root of 261. Give your answer to three significant figures. So we're going to just put that into our calculator and see what it gives us. Okay, there it is. So significant figures, there's no zeros at the start, so we're going to include the 1/6, and then we've got 0.15, right? That 5 is going to push it up to 16.2. Excellent. And does that feel reasonable? There is a quick check you should always do with these ones. These two sides, the shorter sides, should always be less than 19. Is this less than 19? Absolutely. So that means it's a reasonable value. If you got something really close to 0 as well, that's probably unlikely. Okay. Question 21. Write 90 as a product of its prime factors. Okay then. So the way that we do this, and my advice for you, is always start dividing by the smallest number you can. And that's not 1, because dividing by 1 would leave you at 90. We want to start by dividing by 2. If you can't divide by 2, you divide by the next smallest number, 3. And keep on going until you can't get anywhere. So here we split 90 into 2 and 45. Well, great. 2 is a prime number, so that's one of our prime factors. I'm going to put a red circle around it. But 45 we can't divide by 2. But can we divide it by 3? Hell yeah, we can. So 3 and 15. Cool, and 3 is prime. 15 still isn't quite there, but once again it divides by 3 and 5. And now we're left with 2 prime numbers, which means that we've got to the end of our chain. Summarizing this and putting it in index form, we've got 2 times by 3 squared times by 5. And if you wanted to double check, if you type that into calculator, that will get you back to 90. Okay, over here. We've got 2 values. We've got A and B, which are given in index form already, right? They're in powers. Write down the lowest common multiple of A and B. Okay, this is one of those cases where I definitely consider drawing out a Venn diagram. We want to see what's going into our 2 circles. There we go. And why not? We can figure out what these are. 2 squared is 4. 4 times 3 is 12. 3 squared is 9. Times by 2 is 18. Cool. So I'm doing that more for just peace of mind. We've got the 12 circle over here and the 18 circle over here. Remember that the values that are shared are going to go in the middle. Everything that remains is going to go on the outside or in the circle of that number, but not the shared bit. So the 2 values that are shared are 2, right? The B has 1, 2. The A has 2 2s. And the 3. B has 2 3s and A has 1 3. Then 12 has 1 remaining 2. And 18 has 1 remaining 3. Now to find the lowest common multiple, we take all of these numbers we now see in our Venn diagram and multiply them together. 2 times 2 times 3 times 3. 2 squared times by 3 squared, 4 times 9, 36. Equally, you could look at these 2 numbers and just run through their multiples. 12, 24, 36, 18, 36. 36 is the first number that's in both of them. Why didn't I do that in the first place? This method is actually a little bit more foolproof, let's say. Quite often you could get a pair of numbers that don't actually have a common multiple for a really long time. You could be going up to, thousands. And that's not a fun place to be. So doing it this way, you can just guarantee that you're getting the right answer. But some would argue that for 1 mark, you could spot it quite quickly. Question 22. The number of hours H that some machines take to make 5,000 bottles is given by H equals 72 over N. Okay. So the hours it takes is 72 divided by the number of machines. Okay. So on Monday, 6 machines made 5,000 bottles. On Tuesday, 9 machines made 5,000 bottles. Cool. The machines took more time to make bottles on Monday than Tuesday. Yeah, it makes sense, right? Less machines, it takes longer. But how much more? Well, on Monday, we're going to get our hours is equal to 72 divided by 6. That's going to give us 12 hours. And on Tuesday, we're going to get 72 divided by 9. That's going to give us 8 hours. The difference, 4 hours. There you go. So that's it. Nice. Bosh. Quite a nice question for this late in the paper. So things are going to start getting a bit rough now, but we'll work our way through these and see how we get on. So question 23. There are only red discs, blue discs, and yellow discs in a bag. There are 24 yellow discs. Okay. Mel is going to take one of them at random, and the probability that the disc is yellow is 0.16. Ah. Interesting. So I think at this point, it would be in our best interest to maybe start thinking about a table. Right, we've got reds, we've got blues, and we've got yellows. and we've got our probability, and we've got our totals. Okay. Now, I think making these tables makes your life a little bit easier. You don't have to, but in this case, we're really lacking a lot of information. So the probability of yellow is 0.16, and there's 24. Gosh, and that's really all you're told. You're not told very much at all. We're also told that the number of red discs to the number of blue discs is 5:4. But without any real help with our total, we can't actually split the grand total into these associated parts. So let's have a think, right? We know that the sum of the probabilities must sum to 1. We don't know what the total is. But can we use this probability and the 24 to our advantage? Well, we absolutely can. It takes a bit of thinking, but we can totally do it, right? We have some mystery total, the grand total. And if we multiply it by 0.16, well, we end up with 24. Well, that means that our total is equal to 24 divided by 0.16. And that, if we plug that into our calculator, gives us 150. Nice. Okay, so that means over here we've got 150 in total. Amazing. We're then told that the number of red discs to the number of blue discs is split 5:4. But how many blue and red discs are there in total? Well, there's going to be 150 minus 24. In other words, 126. Now you can work out these individual parts by dividing by the total of the ratio, 9, and then multiplying by 5 and 4 respectively. So let's do that. 126 divided by 9 equals 14. So each part is 14. Then multiplying by 5 and 4 gives 56 and 70. Okay. So splitting a ratio into a total, we're splitting, and you could have done this even slightly faster as well by doing 5/9 of the 126 would give red, 4/9 would give 126. Cool, and our objective was to work out the number of red discs in the bag. There it is, 70. So moving on to question 24 now. We want to complete the table. We're taking our x coordinates and we want to know what our y coordinates are. Remember that every equation, right? You're just plugging in x values and getting out your y values. It's a machine where you put in x's and get out y's. All right, let's maybe walk through a couple of these manually. Let's do the 3-1 manually. So y equals 3 squared take away 3, which would be the same as 3 squared is 9, take away 3 is 6. So we just run through this operation a few times. Using 1 squared is 1, take away 1 is 0. Minus 1 is a particularly interesting one. Think about what minus 1 squared is. Minus 1 times minus 1 gives positive 1. Then taking away minus 1, well, you're going to end up with a double negative, minus minus 1. So you're adding another one. This is actually 2. Some would argue that you start to see something quite interesting happening here. Look at the y values around this point. They're actually symmetrical. All right? So with quadratics, you can sometimes see this if they're particularly nice ones. Not always, but sometimes. On the graph, they are always symmetrical around a point, of course. But when you're actually looking at fixed coordinates like this, you can't guarantee it. And then we want to see on the grid, we want to see all of these coordinates. So we can just quickly run through this. Minus 2 is at 6. Minus 1 is at 2. 0 is at 0. 1 is at 0. 2 is at 2. And 3 is at 6. There we go, something like this. Good. Draw it. I'll do my best to give it a draw. There we go. Oh, missed that one. Oh well, don't do that. And curves around there. Ah, that was a poor graph. But you know what? We'll go with it. You guys can hopefully do a better job. I'm gonna. No, I've got to redraw that. There we go. That's a little bit better. There we go. Right. Now for part C, this is a particularly interesting question, and a lot of people get stuck with this. So what's this saying? Well, we've got x squared minus x is now equal to 4. But underneath the surface here, we're actually looking at two equations and just putting them together. The two equations are y equals x squared minus x and y equals 4, right? Notice y is equal to y, obviously, so 4 is equal to x squared minus x. That's what we're seeing here. It's just we've lost the y's. But if we treat these independently, right, we've actually got two lines. We've already drawn the quadratic, that's our x squared minus x, but we haven't drawn on y equals 4 yet. Where is y equals 4? It's here. And all it's saying by these being equal is it's going, well, where do they cross? There it crosses, there it crosses. Then we can look at our x values, and those would be your solutions. They're what values of x would make this thing work. So we're looking at something a little bit bigger than 2, maybe 2.4. And then down here, we're maybe looking at minus 1.6. You could double check these by plugging them into a calculator as well. Obviously, you're not looking for the exact value at this point. You're looking for estimates. Amazing. So this is tough. I don't think that's particularly obvious. Question number 25. Andy, Luke and Tina share some sweets in the ratio 1 to 6 to 14. Tina gives 3/7 of her sweets to Andy. Tina then gives 12.5%, that's a bit weird, of the rest of her sweets to Luke. Tina then says, now all three of us have the same number of sweets. Let's see if she's correct. Okay. Right. Let's see what we can do. What's the best way to explain this then? So let's start by having a look at our ratio. A, L, T, Andy, Luke, Tina, 1, 6, 14. So in the first line, Tina gives 3/7 of her sweets to Andy. So if Tina has 14, and she's going to take 3/7 of her sweets, well, let's work out what that is. So 3/7 of 14. Well, we can think about this by actually scaling up our fraction, 6/14. And 6/14 of 14 is clearly 6, right? So Tina's taking 6 of her sweets and giving them to Andy. Okay. So let's actually just do this in steps. So step 1, 6 of Tina's sweets have left her account, I suppose, and now Andy's got them. So Andy's now got 7, Luke has 6, and Tina has 8. Tina then gives 12.5% of the rest of her sweets to Luke. Now, this is pretty tough. We've got 0.125%. Now, I think it probably requires you just knowing that this is the same as an eighth. It's not particularly obvious that that's true. Maybe if you type in 1.25, yeah, so if you type in 0.125 to a calculator and press equals, it will tell you it's an eighth. Okay, so there's a little tip for you. So in this case, Tina gives 12.5% of her sweets to Luke, so Tina's going to give 1 out of her 8 to Luke. So there you go. After step 2, nothing's happened to Andy. Luke has now gained 1. Tina has lost 1. And look at that. Now she's got all exactly the same. That means they've all got the same number of sweets. Right, and because we're dealing with percentages and fractions the whole way through, it doesn't actually mean they've just got 7, right? They could have any multiple of 7. Okay, something to ponder. It's not I suppose not completely obvious that that's true. Okay. And then question 26. How are we doing? Is this? No, one more question. 26. ABCD is a quadrilateral. All angles are measured in degrees. Show that ABCD is a trapezium. Ooh, that's interesting. Okay, we need to show it's a trapezium. So, let's see what we can do. I think my starting point with this question would be to go, well, I know quadrilaterals add to 360. I've got a bunch of angles in algebra. I know that if I add all of that algebra up, it's got to equal 360. That'll let us get some actual values. So maybe let's start there. 360 is equal to 2x plus 15, starting with A, plus 4x plus 15, that was B, plus 4x plus 8, which is C, and then plus 3x minus 3, which was D. Cool, let's now work our way through this and simplify. Let's combine x's. 2x plus 4x plus 4x plus 3x is 13x. 15 plus 15 plus 8 minus 3. 15 plus 15 is 30. 8 minus 3 is 5. 30 plus 5 is 35. Now, our objective with algebra is always get x's on one side, numbers on the other. So let's start by getting all the numbers to one side. So we're going to get minus 35 and minus 35 like this. That's going to leave us with 325 is equal to 13x. And oof, that's not hugely obvious, but 325 divided by 13 gives 25. Nice. So if each of these x's are now 25, let's go back and work through what we had. So this one over here is going to be 65. 25 times 2 plus 15. This one's going to be 115. This one over here is going to be 108. And this one over here is going to be 72. There you go. There's our trapezium. It's not a square. It's not a rectangle because they're not 90 degrees. There's no relationship between opposites. So therefore it isn't a parallelogram or a rhombus. It's not got one pair of angles, so it's not a kite. It's therefore a trapezium. Last but not least, we have question 27. And here we've got ABC and DEF are two similar isosceles triangles. So similar means that they share the same angles, but they have different lengths. One's been enlarged or one's been made slightly smaller, but their angles remain the same. Now, this means that we can deal with something called scale factors. One of the triangles is essentially a big version of the other. So what we're told here is that, well, our isosceles triangle here has two lengths that are the same. We're actually told on the smaller triangle, DE is equal to DF. So that means that the base of both triangles is these ones on the bottom, and our diagonal lengths are both the same length are the diagonal sides. Now it goes, work out the length of DE. Well, the question is, what is my scale factor? Well, how do I get from 6 to 1.5? I take a quarter. Right? 6 times by a quarter gives 1.5. You could look at this the other way and go 1.5 times 4 gives 6. But because we're going from big to small, let's look at our scale factor this way. And all that means is that to get from AB to DE, I'm going to do 8 times by the same quarter, right? The scale factor remains the same for the whole shape. 8 times a quarter is 2. And there's your answer, 2 centimeters. And well, there's one more. Question 28. Let's crack through this. So we have got a frequency table. And we want to start by finding the class interval that contains the median, right? Median, the D in it there. It's similar to middle. There it is. D's in middle. And that means that we want to find the middle value, right? We've got 120 oranges. How heavy is the middle one? The 60th. So to do this, I'd always suggest that you run through your cumulative frequency, 34. And then after 34, we're adding 29, which is going to give us 63. Look at that. So we're already past 60, right? So that means the first 34 fell into this first bucket, let's call it, or first interval of 50 to 100. But then between 34 and 63, all of those oranges fell into this one. And of course, we're interested in where orange number 60 went. So there it is. It's in the interval 100, W, 150. Excellent. Okay, so we could leave that there. You could continue doing your cumulative frequency. Doesn't really matter. Now, part B asks estimate for the mean weight of the 120 oranges. How do we find a mean? Well, we actually sum up the individual values. So sum of each weight, right? We're dealing with weights here. And we want to divide it by the number of weights that we took, right? The number of observations we had, or in other words, the number of oranges. Right? So we're taking the sum of the values, the sum of the weights divided by the oranges. Now we know how many oranges there were. There was 120. All right, so we can put that on the denominator straight away. But the sum of the weights is a little bit less obvious. Now, unlike typical data, right, you'd get a long list of it. You'd know each individual weight. Maybe one was 57 grams, one was 63 grams, one was 125 grams, one was 220 grams. But here we've lost some of that information. We've put them into intervals, right? So we've lost the individual values. So how do we compensate for this? Well, we're going to assume that in each interval, each orange that is in that interval weighs the middle amount of value. So for example, in this interval, the midpoint would be 75 grams. And we're going to just assume that all 34 are going to be that 75 grams. It might not be true. They might all be 50. They might all be tiny, teeny, tiny oranges. But for the sake of assuming that all of them eventually are that mean, the mean of that value would be 75 grams, we can then assume that that's true. So if we assume all of them are 75 grams, well, we end up doing the calculation 34 times 75. And then we've worked out the weights of these 34. We then need to repeat this for each of the intervals. So next up, we've got 29 times by 125, and then our last interval would be 11 times by 275. A little hint for you guys, do keep an eye out for any weirdly sized intervals. For example, this last one, they could have put like 350, which means that the midpoint wouldn't be an increment of 25. They sometimes do that. Very annoying. So I'm going to quickly just run through this. So 34 times 75, 29 times 125, 27 times by 175, plus, so yeah, careful with typing this in. It's super easy to get this wrong. Times by 225, plus last but not least, 11 times by 275. We want all of that divided by the 120 oranges. Boom. There we get it. Cool. I got our mean weight to be 151.4. 151. 3 significant figures, so we're just leaving it as 151. And there you have it. That's the paper. Wha-bam! Nicely done, guys. I hope that was useful. I hope you've gained some insights there on how to approach that paper. Let me know how you got on. Let me know if any of my explanations weren't clear. If you've got any questions about any of the questions here, please do comment them below. I'll see what I can do. And equally, if you've got any suggestions for what papers or content I should look at next, shout and I will give that a go. Anyways, take care, guys, and I will catch you in the next one. Bye now.